20 years have passed since the release of the Bend-O-Matic BM100. It is this bending robot system, developed by Amada, that has brought about a revolution in the bending field by automating the bending process. This process used to rely on a worker's hunch and skills, and has evolved into a networkable, more automated system. In 2006, the core of BM100 was reborn with significant changes, creating the Astro 100NT cell. If products requiring time-consuming setup increase in quantity, the productivity will be seriously affected. Especially, the bending process is likely to become a bottleneck. Making this process more efficient is the biggest key in improving productivity. With the conventional bending process, there were various problems such as 1. Reduction in actual processing ratio due to increase in high-mix, low-volume orders. 2. Production plan likely to be dependent on machines and specific workers in charge. And 3. Difficult learning curve leads to difficulty in human resource development. In particular, the increasing high-mix, low-volume production was the major cause that prevented productivity from improving. The new bending robot system, Astro Ii 100NT cell, has reduced the shop floor setup and achieved outstanding improvement in productivity by adopting various new functions, automating the process, and making the process intelligent. The Astro Ii 100NT cell is the ultimate embodiment of the shift from using robots especially for mass production to using robots especially for high-mix, low-volume production. The Astro Ii 100NT cell was developed with the concept of 1. High precision and high-speed stable processing. 2. Improvement in workability. And 3. Improvement in operability. Now, let's look at the functions and features of the bending robot system Astro Ii 100NT cell, in the order of these development concepts. The bending portion of Astro Ii 100NT cell is incorporated with the HDS series machine, the next-generation bending machine with high reliability and high achievements. Amada's unique hybrid drive system was adopted for the ram motion. The hybrid drive system uses a highly responsive AC servo motor to control hydraulic pressure. This has contributed to achieving a significant increase in the processing speed and high positioning accuracy to the micron level. Furthermore, the ram motion is made to be adjusted more finely to the 0.001 mm level in the D-axis. For the machine frame, a high-rigidity frame called High Body 100, which was newly designed pursuing higher bending precision, was adopted. The open height was extended to 600 millimeters, which is 100 millimeters longer than in the past, so the machine can do various bending jobs. Moreover, the hybrid crowning system was incorporated at the center of the lower table to prevent middle flex from occurring. This system enables equal distribution of pressure across the table and keeps high longitudinal accuracy of within plus-minus 15 minutes of arc. Also, the hybrid drive system, which is less susceptible to the effects of oil temperature increases, maintains high precision for a long time, with a minimum temporal change of 14 micrometers in 8 hours. So, the system generates minimum loss of energy and waste of hydraulic oil and maintains a favorable operating environment. Based on these important basic functions, the Astro Ii 100NT cell has introduced many advanced mechanisms that realize stable, high-speed and high-precision processing. In the Astro body, a new robot system with a renewed design was adopted. This system enhances the access speed by approximately 20% compared to the past. High productivity will be achieved by using both this system and a high-speed and high-precision back gauge that achieves a y-axis speed of 60 meters per minute and an l-axis position repeatability of plus-minus 0.003 millimeters. The back gauge is equipped with a high-precision potentiometer that detects changes in workpiece travel distance and controls the robot movement. The potentiometer constantly monitors precision by repeatedly giving gauging directions to the robot until the back gauge error meets the processing standard. This enables stable, high-precision processing for a long period of time. Moreover, the Astro Ii 100NT cell adopted the thickness detection system, called TDS, which reduces thickness variation impact on angles and achieves high-precision bending. TDS measures subtle differences in sheet thickness with a stroke distance from the pinching point and controls the D-axis. TDS quickly responds to thickness changes and constantly adjusts load to an optimum value. In test processing using TDS, it was proved that TDS's thickness adjustment feature works effectively even for sheet thicknesses with just 0.03 millimeter difference. A high-capacity new auto tool changer mechanism, which holds a much larger number of tools and stores more than 10 kinds of tools, contributes to significant improvement in tool setup efficiency and productivity. The enhancement of the access speed by approximately 25% has greatly shortened the tool changing time. An accurate and speedy tool change, which previously could only be done by skilled workers, can now be done automatically. In addition to a punch and die auto-invert mechanism, the Astro Ii 100NT cell is equipped with a punch and die auto-reverse mechanism that reverses the punch and die positions by 180 degrees. This allows more flexible production with minimum setup. Furthermore, a bending indicator, BIJ, can be used on the automatic tool changer by making the angle sensor wireless. With the speedy angle detection function, by use of an inline spring-back method, and the high-precision bending angle correction function that can adjust angles to be within plus-minus 15 minutes of arc, trial bends for repeat orders, which used to be essential in the past, were reduced to the minimum, and work efficiency was improved dramatically. Additionally, the Astro Ii 100NT cell has a variety of new functions, including the new automatic gripper changer called AGC, which can hold 6 grippers maximum. The Astro MP20 automatic hand changer called the AHC mechanism, which is a load-unload device with a high-speed cycle of approximately 25 seconds with significantly improved functions. A load correction mechanism that fine adjusts the robot's material loading position by measuring the position of the blank materials with a CCD camera. And a newly designed automatic buffer table with a Y-axis position adjustment function to respond to flexible position changes. The adoption of these new functions will ensure your production is more efficient. With bending robots performing complex 3D motions, the creation of the working data is also important. Dr. Abe Astro is a next-generation automatic programming system developed exclusively for the Astro series. It can automatically create all data necessary, from tools to use, bending sequence and tool layout, to gripper selection and robot motion. Dr. Abe Astro has realized efficient offline programming in the office. In addition, new loading-unloading software exclusively optimized for the Astro Ii 100NT cell has automated the loading-unloading of products. The simulation function, which precisely reproduces the actual machine motions, has significantly improved the efficiency of internal setup for new products, which would have taken a lot of time in the past. The Astro Ii 100NT cell can be connected seamlessly to Amada's network system. It can respond easily to automation demands by adding state-of-the-art hardware and software. The Astro Ii 100NT cell can also be used promptly as a machine centering in the Virtual Prototype Simulation System, abbreviated VPSS, which aims to realize new digital manufacturing. The Astro Ii 100NT cell is the ideal automation system, capable of responding flexibly and rapidly to various production styles, including high-mix, low-volume production and long hours of continuous operation. The future of bending automation starts with this Astro Ii 100NT cell.